Hello, everybody. Hi.
Really good. Yeah.
Good morning. Good morning. Welcome. Thank you for all being here. It is actually not as early, but yes, for a little bit of fun. So hi, thank you guys all for being here. One of my first speaking, like my first journey of public speaking about security happened at a BSides, actually BSides Connecticut, back in 2019. I gave a talk about a vulnerability in Zoom that I found back at that time, and had a lot of fun with it. Took that to ShmooCon and was going to go other places, and then promptly COVID hit us. So conferences ended, and this was a talk that I've come up with as a result of, I'll talk about the Dan Kaminsky Fellowship. This is a talk I've given at Black Hat, DEF CON, BSides Las Vegas, taken all over the world, Japan and Italy, and now I'm happy to present it to you all here now today. So welcome to Scaling the Security Researcher to Eliminate Open Source Security Vulnerabilities Once and for All. Is there a way that I can get rid of the bottom bar, or is that fixed? And the answer, if the answer is it's there, that's fine. Anyways, I'm gonna get started while you fidget with that. I'm not.
You click that.
Is that, because it's not, Zoom's not coming through on my computer, it's just, don't worry about it, it's okay. All right, anyways, hi. Who am I? My name is Leitschuh. I'm a senior software security researcher for the Open Source Security Foundation, which is a sub-foundation of the Linux Foundation. I work on a project called Project Alpha Omega. I was the first ever Dan Kaminsky Fellow. I'm a GitHub star, a GitHub security ambassador. You can find me on Twitter at Leitschuh and at GitHub on the same handle. A little bit of a disclaimer. This talk does cover stuff that is proprietary, but everything is available for free for open source. So you can use this stuff, all of this stuff, for free for open source and for your open source security research. Some of this stuff you might need a license for in a corporate setting. Okay, that jumped ahead. So this work was supported by Project Alpha Omega, the Open Source Security Foundation, which I currently work for. It was also supported by the Dan Kaminsky Fellowship at Human Security. I was lucky enough to become the first ever Dan Kaminsky Fellow. For those of you who don't know, Dan was best known for, I sadly never got the opportunity to meet Dan. He was very well known in the security community. He was best known as the hero of the internet back in 2008 for finding and fixing a widespread security vulnerability in DNS back in 2008. And after Dan passed, the Dan Kaminsky Fellowship was created to celebrate Dan's memory and legacy by funding open source work that makes the world a better and more secure place. And I was fortunate enough to have the opportunity to take on that fellowship in its first year. Let's jump straight into the spoilers. I generated pull requests. I generated a bunch of pull requests to fix a security vulnerability called zipslip. I generated 164 pull requests to fix zipslip across the Java system. But what is zipslip and how did I do this is what the point of this entire talk is. So this entire journey started with a simple security vulnerability. And it was this: the use of HTTP to resolve dependencies in my company's Gradle build. Now, this vulnerability, you might ask me, why is this important? Well, if you're using HTTP instead of HTTPS to resolve your dependencies in your company's, in your build, somebody can, attack from the middle, inject code into your jar file that you're downloading, and then run code on your machine. And this vulnerability doesn't just exist in Gradle build files, it can also exist in Maven. This is where it appears if you're looking at a Maven XML configuration file. This is jumping ahead faster than I wanted to. And then also, you can see that this also appears in the upload. So this is usually with credentials. It's going to your artifact server. Oh, quiet Siri. So this is usually with credentials, and it's uploading stuff into your artifact server as well. This vulnerability is everywhere. It impacted organizations like Spring, Pivotal, Red Hat, Apache Foundation, Kotlin, JetBrains, Jenkins, Gradle, Groovy, Elasticsearch, Eclipse Foundation. It also impacted Oracle, the NSA, LinkedIn, Stripe, this open source projects for organizations all over the world. And I reached out, so Maven Sonar Type is the PyPI of the Java ecosystem. NPM to the JavaScript ecosystem. Maven Central is that. And Maven Central is run by Sonatype, and they looked at their traffic and saw that 25% of their traffic in 2019 was using HTTP instead of HTTPS to resolve their dependencies. So this is a major predominant artifact server in the Java ecosystem. So how do we fix this? Well, I pushed forward an initiative that on or around January 15, 2020, all of the major artifact servers, unlike the other languages, Java actually had a couple of major artifact servers at play. That all these major artifact servers in the industry would stop supporting HTTP in favor of HTTPS only. And they did it. There's a bunch of blog posts announcing that they were going to do this, giving people warnings that this was going to happen. However, when I reached out to Maven Central again, they said that in 2020, January 2020, just before we were about to pull the plug, we'd only seen a 5% drop in the amount of traffic that was using HTTP instead of HTTPS. So we still have 20%. So you can imagine what might have happened on January 15th, 2020. Broken software. Lots of posts on Stack Overflow. People like, why is my build suddenly broken? And I'm like, that's because of me. So, but we stopped the bleeding. But what about the other repositories? So these Maven Central, JCenter, Spring, Gradle, Plugin Portal, these are only the predominantly used artifact servers in the industry. There are actually a lot more. You'll see if you look at any open source project in the Java ecosystem, you'll see other artifact servers for random companies that have hosted artifacts. They don't publish to Maven Central. So Java ecosystem's build infrastructure is actually way more distributed and coming from a lot of different places than other languages, which are all centralized on a single central artifact server. How do we fix the rest? And I said, well, let's just go fix the problem. Let's generate pull requests to just give the maintainers the fixes for these vulnerabilities. And so the question was, how do we do this? Well, the first thing, CodeQL is as a simple query language that lets you write queries to find security vulnerabilities across open source projects owned by GitHub. And so using this little simple CodeQL query, I was able to detect this vulnerability across the open source ecosystem. CodeQL scans hundreds of thousands of open source projects, and you can run those queries against those projects to find vulnerabilities. And for this very simple query, it's not very much code, and then a little bit of associated documentation. GitHub awarded me a $2,300 bounty for this little chunk of code. And then so from that CodeQL query, I was able to get a list of vulnerable projects, and I wrote this pull request generator. And it was the first thing was run on my laptop, Python-based, wrapper over GitHub's Hub CLI. It had one nasty regular expression, and a lot of logic for bouncing off of GitHub rate limiter. And this is the engine, underlying. And you'll see there's this regular expression here. And you say, okay, so this regular expression is clearly fixing XML. And you're like, why, Jonathan? Why are you using XML to fix, or why are you using regular expressions to fix XML? And the answer is really annoying. All parsers, almost all industry standard XML parsers in the industry, if you feed that file in and then modify the XML, when you dump it back out, it comes out in the format the XML parser dumps it out in, not in the format that it came in. All these parsers don't preserve the formatting. So if you want to make targeted changes in files that have tabs, spaces, braces on new, all these formatting changes, you have to use something like regular expressions. Really annoying. The problem with regular expressions is when you use regular expressions to solve your problems, now you have two problems. The original problem you had and the regular expression. But it worked. I generated a ton of pull requests to fix the security vulnerability across open source. This is a very, you can see it's very targeted, right? No matter what the formatting was, I could fix it with this regular expression. I generated 1,596 pull requests to fix this vulnerability across the open source system. And as of now, today, this is back in 2020, I did this. I have about a 40% merge rate for this. And for this work, GitHub awarded me a $4,000 bounty from the GitHub Security Lab bug money program. So I got hooked on this idea of bulk pull request generation and fixing security vulnerabilities at scale, and submitted that as an idea to the Dan Kaminsky Fellowship. And I was lucky enough to have that accepted as the project that I could work on for a year, funded. This is my GitHub contribution graph for 2020. And it actually shows those two massive peaks generated lots of pull requests to fix security vulnerability scale. So I have a problem. I have ADHD, and I don't consider my ADHD to be a problem. But I do love chasing squirrels. And I will do that by looking through advisory databases, github.com/advisories or something like that. And I'll be like, huh, that's an interesting security vulnerability. I wonder where else that is. And the answer is everywhere. You can take a very simple chunk of code that you'll see is vulnerable and be like, I wonder where else this is. And you'll just use a code query or something like that. So the problem that I have is I'm finding too many security vulnerabilities. This is an example. This is the result of a code query search for a vulnerability called zipslip. Again, we will get to what zipslip is, but this was on a site called lgtm.com, which used to be owned by GitHub. They've since turned it off, but you could scroll through pages and pages and pages of open source projects with this exact vulnerability all across open source. And so how do you deal with a problem of that scale where it's just like, we just have the results, we don't know, like you can't reasonably report this to maintainers everywhere. I'm finding too many security vulnerabilities. I need automation. So we need automated, accurate transformation at massive scale. This is where Open Rewrite comes into play. Open Rewrite is an open source project, predominantly written in Java, and it's available under Apache licensing. You can use it in your own projects, write tests. So what is Open Rewrite? Well, let's start out with what an abstract syntax tree is. So an abstract syntax tree is what your compiler works on when you're compiling source code. The thing is that the abstract syntax tree, you'll notice that when you take this chunk of code, the compiler turns it into that tree structure in order to work on it. But if you were to dump that tree back out into source code, you'll notice a bunch of all of our namespace is gone, all of our tabs are gone, all of our comments are gone. It's because the compiler doesn't care about that stuff. The compiler doesn't care about that extra information, so it throws it away. So what we need is something that is this format preserving abstract syntax tree that turns it into this tree structure, but still preserves the white space, tabs, comments, all of that stuff. Yeah, one does not simply format the entire source file when you're fixing security vulnerability scale. You got maintainers being like, thank you so much for fixing this, but your code doesn't match my style. Go change it all, and that does not work. So you need to be able to target specifically the lines you want to fix. And on top of it, you can generate new code that matches the surrounding formatting. So if that project uses braces on a new line, tabs, whatever it is, you can generate new code matching the surrounding project's standard formatting, because Open Rewrite, as a part of parsing the source code, figures out what your project's general formatting is, and will then try to match that no matter what it is. Additionally, it's fully type attributed. Is that log for J, SLF for J, log back? What logging framework is that using? Might be important to know to fix a security vulnerability. I can't imagine there ever being a critical security vulnerability in logging framework. No, that would never happen in our industry. No. On top, because of it's fully type attributed, it gets this very, very dense graph. Actually, there's about 6,000 nodes missing from that left graph because it would be too dense and you would just see fuzz. And then on top of that, when you're trying to insert new code into an abstract syntax tree, these abstract syntax trees are very complex. And so you want to be able to place that new code into your source code in a very targeted way. Let's say this is the fix for zipslip. Let's say we want to insert this into our source code. Again, we will get to zipslip later. You can put that code that you want to insert into a string, and the templating engine will let you insert this, generate that AST, and insert it into the code. It also comes with a coordinate system for stating exactly where in the AST you want to place that new chunk of code that you just written. And so that lets us take this vulnerable code and insert this fix into the source code, matching the formatting, and fix the security vulnerability. So what's possible now? What other vulnerabilities can we fix with the unlock that Open Rewrite provides? I used Open Rewrite to fix 3 security vulnerabilities across open source: temporary directory hijacking, partial path traversal, and zipslip. Let's talk about those 3. Let's start with temporary directory hijacking. So what is temporary directory hijacking? So temporary directories on Unix-like systems are shared between all users. So I was surprised to find that out when I found that out. I was like, wait, each user doesn't get their own temporary directory? No, every single temporary directory, there's one temporary directory for Unix-like systems. So when you're creating a temporary directory like this, you'll see that this was actually a very common pattern in Java. So what is going on here? Well, someone is trying to create a temporary directory instead of a temporary file. The problem is that prior to Java 1.7, there did not exist a way to create a temporary directory in the Java standard library. So people would create a temp file, which gave you a randomly named file with a pseudo-random number generator or a CSPRNG name. They call delete on it, and they call makedir. The problem is that, yes, if you ask Stack Overflow how to create a temp directory, you get this answer, but unfortunately you get a security vulnerability as a result of it. So why is this vulnerable? Well, there's a race condition here. The race condition is because makedir returns false if it fails. It doesn't throw an exception. Ooh. I need to turn off the swipe functionality if that's what's got on. Okay. So, stay. So this is a fix for it. But this is actually still vulnerable. And the reason it's vulnerable to a different vulnerability. This is actually vulnerable to temp directory information disclosure because this makedir makes that directory using the default POSIX permissions on the file system. So that directory is actually still visible. All the contents are still visible to all of the local users. So you put sensitive information into this directory, other local users can see that the contents of that file. So this is the real fix. This is a Java API introduced in 1.7, very old API. And so a lot of people have not written their code to fix this vulnerability, but there is a new way to do this. And I got a bunch of CVEs for this vulnerability across the open source ecosystem. And then I generated pull requests. I actually generated 64 pull requests to fix this vulnerability at scale. And this is what it looks like. You can see these very, very, simplistic little changes that we can make to just fix this security vulnerability. In addition, we can do more complex fixes, right? We don't need those file if checks anymore. We can get rid of those. And this is what Open Rewrite allows us to do. Vulnerability number 2, partial path traversal. So what is path traversal vulnerabilities? Let's assume that you have 2 users on a file system. You have user Sam and user Samantha. And you have logic, you want to sandbox some bit of logic to only be able to access user Sam. So partial path traversal allows an attacker to access a sibling directory with the same prefix. So again, user Sam, user Samantha, because user Samantha starts with user Sam, you can bypass this. So what does this vulnerability look like? Well, this is a very common pattern you'll see across software. You'll see this starts with check, get canonical path starts with. And this starts with check is using a string comparison. The problem is that get canonical path, which you'll see called twice here, is used to normalize the file path. So it gets rid of the dot, dot slash. So when an attacker is trying to do a path traversal payload, you're comparing the normalized path. So this is, you take user's file Sam, and then you call get canonical path on it. This actually returns a string. And you notice that string is user/Sam. What's the problem with that? We're missing that trailing slash that we had when we started this with this whole thing. So then what happens is you have this user supplied value that comes in, right? And user Sam, we've had that trailing slash stripped off. And now we've got an attacker come in with Samantha/Baz. And that gets normalized here. And now we've got user/Samantha/Baz starts with user/Sam. And that exception does not get thrown. And so this logic is very easy to bypass. So what is the fix for this? Well, one of the fixes for this is to put this file separator character back in. I found this on the web. Thank you, Siri. The better fix is to use the path object, which is introduced in Java 1.7, which lets you compare these things safely. So this is the good thing. This is what we actually want to see. So how do we find this vulnerability? Well, we're looking for this string starts with call, and we're looking for the qualifier and it to be this get canonical path, and the argument to be this get canonical path, right? But we don't want to find places where this vulnerability is not present because somebody has put this code in where they've actually fixed the vulnerability. We don't want to fix, because again, maintainers will be really pissed if you fix a vulnerability that's not a vulnerability. They'll just be like, why? Well, stop bothering me, go away. But it can't be that easy, right? Problem is, software, people write code in a lot of different ways. So what if they pull that qualifier into an argument, into a variable, or they pull that argument into a variable? Or what if they have the fix, but it's in a variable? How do we detect this? How do we know if it's not vulnerable or vulnerable or not? This is where we need data flow analysis. So data flow analysis allows us to track what variables, where variables have been assigned throughout our code base and where things are coming from and what they'll be. And data flow can also let us do more complex things, like it'll do intermediary things, if it flows through a ternary, other transformations that may occur on those objects. You can determine that and figure that out and know what's going to be at runtime, or try to determine what it will be at runtime. The data flow allows us to uncover hard to find vulnerabilities and helps us prevent false positives when we're detecting and fixing these vulnerabilities. And by show of hands, has anybody here written any code flow before? Hey, okay. So have you worked with our data flow API?
A little bit, yeah.
Okay. If you are familiar with CodeQL's data flow API, I have made OpenRewrite's data flow API to try to match that, because it was my sanity trying to map my brain's model of data flow and control flow to OpenRewrite. So if you are familiar with CodeQL, you can try to translate your knowledge between those two fairly easily. And so when you have this, you can use this to then fix. You can see that we've tracked that there is a vulnerability there for that starts with call, right? All we have is that string starts with, and we're able to determine that it's vulnerable and fix it appropriately. As with any good story, this has a bit of an example case, vulnerability disclosure drama. I found this vulnerability in the AWS Java SDK. The AWS Java SDK is used to, you can use it to download the entire contents of an AWS bucket on your local system. They have this bit of logic where they're trying to compare this key, which is coming from the bucket, with the directory that it's being downloaded into, to make sure that we're not escaping. This key is not a path traversal payload attempting to escape this root. And you'll see that this leaves root method is used as a guard that will say cannot download key as relative path resolved outside of the parent directory. And so that was a vulnerability. That's partial path traversal. And as with any good story, this vulnerability disclosure had a little bit of disclosure drama. This is an email conversation I had with Amazon. Hey, Amazon, Amazon said, hey, we'd like to award you a bug bounty. However, we need you to sign an NDA. And I said, I don't normally agree to NDAs. Can I read it first before potentially agreeing? And Amazon came out with this great line. We're unable to share the bug bounty program NDA since it and other contract documents are considered sensitive by the legal team. I still have not gotten that money. But yes, they did apologize for that. And they said, that's not what we intended. And I'm like, okay, sure. But I still haven't gotten the money. Anyways, vulnerability number 3 is zip slip. So show of hands, who's familiar here with path traversal payloads? I know we talked about partial path traversal, but are you guys familiar with path traversal payloads? Okay. Path traversal payloads are an attacker attempts to supply data like ... and then some file path as an attacker supplied value, and that gets appended to your intended directory, and then that resolves, and you are able to manipulate the file system in a way that you did not intend. So similar to partial path traversal, but now full path traversal. So zip slip is zip files fundamentally are maps. The key is the destination directory that you want to put the file in, and the value is the compressed contents of the file. And so you iterate through those key value pairs usually in zip unlock, unpack logic. I overtime. What does this vulnerability look like? Well, it looks like this. That's a lot of code. Let's narrow it down a little bit. So we have zip entries, we're iterating over those. This is the important bit. We've got this untrusted user value, e.getName, which is that key, which you can't trust because it's being supplied by an attacker, potentially. And you've got this file output stream that's being created from that untrusted input and from this output stream. So we're looking for the flow from this name to this file output stream. That's the data flow we're looking for. So zip flip is complicated. And the reason the zip flip is complicated is because this is the vulnerable code. This is a valid fix. The problem with zip flip is that while this is a valid fix for this vulnerability, so is this, right? Both of these things adequately protect against this vulnerability. And there can be more complicated things like this. So how do we just determine if this is vulnerable or not? We need control flow analysis. So control flow analysis allows us to differentiate between these two chunks of code. And what is control flow analysis? Control flow analysis is a graph. And you compute it by, and you break your code down into two structures. Basic blocks, which are the set of contiguous instructions that will occur without a jump in a program. And condition nodes, where the program will branch. And so using that, we can take this chunk of code and we can compute the control flow analysis graph for this chunk of code and see that there's this guard here that prevents us from reaching this code. It'll always go to this IO exception. It won't reach this code if this guard is present. And so because of that, we can say this is not vulnerable code with our logic. And so because of that, we can determine that there is vulnerable code here. When there is vulnerable code, we do need to fix it. We can differentiate between those two things and only fix the vulnerabilities in places where the vulnerability is indeed present. And we can do even more complicated things because of the power of rewrite. We can clean up the code a bit more and fix these vulnerabilities. Yes. So let's talk about pull request generation. So we've talked about actually the fixing the vulnerabilities, right? Detecting, fixing without rewrite. How do we actually generate the pull requests and give these things to maintainers? You got a security vulnerability, everybody gets a pull request. So let's talk about the problems with pull request generation. How fast can we generate pull requests? Well, when you're trying to generate a pull request against GitHub API, you got three different things: file IO, Git operations, GitHub API calls. You got to check out the code, download the repository locally. You got to apply the branch and commit the change. You got to fork the repository on GitHub. You got to rename the repository on GitHub. You might be like, why do I need to rename the repository on GitHub? Well, if you're forking thousands of repositories across GitHub, you're very likely going to encounter projects with the same name. So let's say that I've got the project rewrite for one organization, the project rewrite for the other organization. When I fork both of those against my account, GitHub will say, great, you got the first one. You've already got a repository of that name. Can't fork it. So you've got to rename every single repository to another name. And you got to push the changes, then create the pull request on GitHub. You'll notice there's 3 API calls on GitHub, or 3 API calls to GitHub. Thankfully, this has been recently merged into 1 API call. So we've got 2 API calls. However, GitHub asks that you wait at least 1 second between every write request. So if you're generating thousands of pull requests and you've got at least 2 API calls per, you've got to wait at least a second. And then on top of that, GitHub is another secondary rate limit that's just like, you're doing stuff too fast, stop. And that one's the really annoying one to work with because it doesn't really give you a time for how long you need to wait. So you just kind of have to wait and like procedurally back off and just like hope that you've got the next request right before they're happening. So yeah, if GitHub could stop rate limiting their API so aggressively, it would make my life easier. I would be able to do this faster, yada, yada, yada. So we made it this far. We've detected the vulnerability, we've detected the style, we fixed the code, we've bypassed the rate limit by mostly just waiting more. How do we do this for all repositories? So this is where Modern comes in. So Modern is free for open source projects. It has over 31,000 repositories indexed, both not just of Java, but also some other languages, Kotlin, Python. You can run open rewrite transformation scale across these 31,000 open source projects. And you can generate and update pull requests using their platform. And they have over 800 recipes include complete framework migrations. You can migrate from Spring 1 to Spring 2, JUnit 4 to JUnit 5. You might not think about your testing framework, right? JUnit, which is the testing framework for Java, has a security concern. But currently, you can't run the latest version of Spring, which I presume most of you are familiar with Spring for its security context and making sure that's always up to date. You can't write code using the latest version of Spring without updating your testing framework. So your testing framework that you're using can be a blocker to your security, improving your security posture across your organization. And then on their public SaaS, public.modern.io, you can use their SaaS to generate pull requests. And so that's actually what I did. You can see, there we go, start playing, great. So I have a set of results that I've generated to fix a security vulnerability. I can say I want to create the pull request for it, set the branch name, set the commit message, set the commit title, set the organization that I'm going to create the pull request from, pull request title, give my GPG key, and suddenly I'm generating pull requests as me from their SaaS using my GPG key, so all the commits have been signed. Thousands of repositories right there. There we go. But there are more than 31,000 repositories in the world, right? They used to say 7. They was there at the time when I gave this talk at Black Hat. They only supported 7,000 repositories on Modern. Now they have 31,000 repositories on Modern. This is where CodeQL comes in. CodeQL scans over 100,000 open source projects, and you can run your queries at scale across their open source. And they have 35,000 Java projects that they are indexed and aware of that you can run your queries against. And so once you have a CodeQL query that you've written that finds a security vulnerability at scale across open source, you can then turn that CodeQL query. You can take that list and give that back to Modern and say, hey, please become aware of these repositories. And they will then add those to their CSV file list. They will go index them for you, and then you can run your recipes against those projects. So finally, let's go generate some open source pull requests. That's what I did. I generated pull requests for this vulnerability across open source. Temporary directory hijacking, zip slip, partial path reversal. Statistics. That first attempt that I did pull request generation back in 2019, 40%. GitHub actually did this one. This was not me. Sorry, no, this one was not me. These are the new ones. Temporary directory hijacking. I generated 64 pull requests. Partial path reversal, 50 pull requests, and zip slip, 164 pull requests. The thing about zip slip actually is the funny thing is zip slip partial path reversal is often occurs in the context of zip slip. So you'll actually, even though this only shows up as 50, I actually use a zip slip actually applies the partial path reversal fix first, if relevant. Okay, there we go. So in 2022, I generated 600 plus pull requests across open source to fix security vulnerabilities at scale. I've been a part of generating north of 5,200 pull requests to fix various different security vulnerabilities across open source. One unlucky project was the recipient of all 3 of my pull requests. Zip slip, partial path reversal, and temporary directory hijacking. I don't think this pull request has actually been merged, which is something that I should go deal with at some point very soon. And also, you should see that star count up there. 1,000, yeah, that's concerning. And this is my contribution graph for 2022. So let's talk in the time we have left about best practices for bulk pull request generation. First thing, messaging. Maintainers are people. And I know we're throwing automation at a problem. There's this great saying out there. All software problems are people problems in disguise. And we are definitely throwing software at a people problem, right? Maintainers are very familiar and kind of gotten comfortable with the idea of having bugs reported to them, but not necessarily security vulnerabilities. So you have to be gentle. So communicating to them stuff like that you are not, that you're a real person, that you'll be receptive to their responses, that you're not just going to ghost them after you've given them this pull request is important because it means that you're generating a rapport with them, engaging with them. It's important to not just do this and then leave the ecosystem with a flood of disclosures with maintainers that are like, what am I doing with this? Some finer lessons on this point. Lesson 1, sign off on all commits. You might ask, why? What is this? So sign off is a git commit flag. And this is what it looks like. It shows up in the commit. And you would say, why? Why do I need to sign off on the commits? Well, there was a lawsuit, TLDR lawyers. Otherwise, your pull request will be rejected by evil dragon bureaucrats. So just sign off on your commits. It'll make your life easier, trust me. Lesson 2, be a good commitizen. GPT sign your commits. Then it'll show up as verified like it does over there. It's coming from you, and then it won't be like Linus Torvald, where he's been impersonated on GitHub multiple times. Lesson 3, CCOM. I don't have time to dive into this, but it's a commit message format for security vulnerability fixes. So if you want an auditable, traceable sort of way of determining was this a security fix or not that was in this commit, consider looking into CCOM. There are risks to using your personal GitHub account. By a show of hands, anyone here familiar with GitHub's Angry Unicorn? Nobody here is familiar with GitHub's Angry Unicorn. Wow, I use GitHub a lot. This is GitHub's Angry Unicorn. This page is taking too long to load. This was my GitHub profile page for most of 2020. I broke my GitHub account. So I don't recommend using your GitHub account, but I also do recommend using your GitHub account. It's like a double-edged sword. I recommend using your personal GitHub account because you're dealing with real people, and so it's easier to engage with them as a real person than it is through an automation account. But you may break your GitHub account. So, yeah. Second, lesson 5, coordinate with GitHub. This is the security email for the GitHub Security Lab. Let them know you're going to do this. Say ask them to review your changes, stuff like that. They're happy to collaborate with you. And then lesson 6, consider the implications. I got this issue open against my repository shortly after beginning this work. Is this responsible disclosure? I don't use the term responsible disclosure. I use the more nuanced term coordinator disclosure. But to answer both questions, no. This is full disclosure publicly of a security vulnerability in an open source project. By doing this work, I have been ODing open source maintainers. That's unfortunate. And there are new things that have come out since I did this work. If you look, GitHub now has a way of privately reporting vulnerabilities via private vulnerability reporting. It is currently opt-in. It's not something that is automatically enabled on all GitHub repositories. And so we have this problem of how do we give security vulnerability reports to maintainers in a responsible, ethical way? And the problem is also the scale of the problem. Hundreds, thousands of security vulnerabilities that need to be reported and get into the hands of maintainers. And there's only one of me. How do we do this in a way that reasonably scales? And so this is a problem we've been tackling as a part of working with the Open Source Security Foundation. I've been running a working group inside the Open Source Security Foundation trying to figure out the best practices for this. But the answer is it's hard because public pull requests are standard. We're trying to do something privately, and that involves coordinated disclosure, timeline disclosures. Like it's a complicated, fickle thing to deal with automation. However, I believe that we need some way to fix these vulnerabilities. We need to get these vulnerabilities fixes into the hands of maintainers. So, in conclusion, as security researchers, as security professionals, I believe we have an obligation to society. We know these vulnerabilities are out there. We, as security professionals sitting in this room, understand these vulnerabilities. We have seen them in pen test reports. We can articulate them to our peers. We understand the impact these vulnerabilities can have on our organizations and the customers and the people that we support. We understand that. Spoiler alert, most software developers don't watch Black Hat talks, don't watch DEF CON talks. We do, but the people that are writing this code don't. There's a statistic out there that GitHub has published. For every 500 developers, you have one security researcher. We are heavily outnumbered in this industry. And so how do we best leverage our knowledge of math, science, technology, security, scale our knowledge to get these vulnerabilities fixed across our organizations and across the industry? I believe that automation is the best way for us to do that. But automation with compassion and automation working with maintainers in a collaborative way. With that, I want to leave you with one final quote. This is from Dan Kaminsky. It's on his Twitter profile, and it remains there to this day. We can fix it. We have the technology. Okay, we need to create technology. All right, the policy guys are mucking with the technology. Relax. We're on it. I want to leave you with a couple of final notes and just things to do. Learn CodeQL. Seriously, it's an incredibly powerful language you can use to find vulnerabilities at scale. Contribute to Open Rewrite, and you can deploy your security fixes at scale. You can join the GitHub Security Lab and Open Rewrite Slack channels to discuss those technologies with the maintainers. Also, consider joining the Open Source Security Foundation, where we're discussing this and other critical topics surrounding securing open source. It's an organization under the Linux Foundation. The meetings are public. There's a public community calendar. You can join any of the meetings that you want to join at any time. Just look up the Open Source Security Foundation and consider participating in the community that we've been building there. And finally, I want to thank the Open Source Security Foundation and Project Alpha Omega for supporting this work, Modern for working with me on this, Human Security for the Dan Kaminsky Fellowship that enabled this work over the past year, Lydia Giuliano, the speaker coach that I worked with to come for this talk, and Shyam Mehta, my intern last year, who worked with me to create data flow and control flow analysis on rewrite, and also came up with the graphics that you saw for control flow. Yeah, that's me. Thank you. I have time for questions. I think yes, you do. I have 15 minutes time for questions. Yes.
Do you guys now have these program analysis techniques in Open Rewrite for everybody to use, or is it like a private code base?
So it's broken up into a couple different code bases. Oh yeah, so the question, as far as I understand it, is are the program analysis components available for free, or is it commercial? I don't work for Modern. I don't work for, so all of the stuff, so I wrote Open Rewrite's data flow and control flow analysis from scratch. It did not exist. It now exists. It's not perfect, but I was all done in an open source repository on top of their code bases. So this separated into a separate repository from their core repository. So the languages themselves live predominantly in Open Rewrite / Rewrite. That's where they have Java, Groovy, Kotlin. No, Kotlin's in a separate repository. And then there's another repository called Rewrite Analysis, and that's where control flow and data flow analysis lives. And then the application of that lives in another repository called Rewrite Java Security, which is where the security recipes like zip, slip, partial path traversal, and stuff like that actually fix the vulnerabilities live. But all these are open source. They're all Gradle-based projects. You can download them, run them on your local machine. Unit tests, for everything. So you can try it out and play with it and figure out. You don't need to get your code deployed on their SaaS to try it. You can just tinker with it locally and play with it and find and develop fixes. Yes.
So I think the pull requests are awesome, right? They make sense to do because it's stuff that's out there now.
Yes.
How much time should we be spending doing that versus fixing the source, right? The source of like zip slip is not the open source user who used it. It's the API.
Oh, I agree. So I played this game. XML parsers. Basically all of the XML parsers built into the Java standard library are vulnerable to XML XXE by default. I reached out to Oracle and said, hey, Oracle, this vulnerability that exists in all of your XML parsers, why? Can we fix this? And they said, well, it'd be an API breaking change, so we'd have to go through a formal JEP process, which is the Java improvement process. I don't think that JEP has been opened, so I was like, okay, fine. I think this is a security vulnerability that exists in the Java standard library. We should get that, we should get it fixed, but if not, we should just at least publish, we should state it publicly this is a security vulnerability. So I went, hey, Oracle, has there been a CVE issue? They said no. So I went to the CVE board and I said, CVE board, Java standard library has this security vulnerability by default. You know, there should be a CVE for this. The CVE board stance was, to summarize, just because a vulnerability exists, just because it's vulnerable by default in an API does not necessarily make itself is not necessarily a vulnerability in itself. And so they were not willing to issue a CVE for that vulnerability, even though it's a standing, like OWASP has an entire document on how to fix that vulnerability that's very public. So at a certain point, you just say, can't fix it in the source, right? I can't, you try, that's one of the things that so I've been working on the specification that defines how to do bulk worker generation to fix this stuff at scale in a way that's ethical, appropriate, you know, as defined by the Open Source Security Foundation. One of the first things is fix it upstream first. Try to fix it upstream first. If you can't fix it upstream, then this is the next best option, right? It's like, do the best thing you can, but when you are limited, this is the fallback, right? It gives us a solution for maintainer won't fix upstream maintainer won't fix security vulnerability. Good question. Yeah.
From an enterprise side, are there any tools out there or any packages out there that include these tools, like GitHub Advanced Security or anything like that?
So GitHub Advanced Security includes Stokewell. Modern is a corporate entity. They are the primary maintainer and owner of the open source project, which is OpenRewrite. OpenRewrite itself is completely open. It's well, with some caveats, but it's an Apache 2 license project, Java-based project. So you can try out the recipes, run the recipes against your local stuff, but if you want to run it against your entire enterprise, you're gonna have an easier time with purchasing their SaaS. But you can, if you can get all your projects checked out locally, you can just run the recipes against all of your projects locally if you want to, and have the same effect. It's just they add the convenience of their SaaS and making it so you can run them across all your projects. So,
and then trying to shift this left to develop time.
yes.
Are things like Open Rewrite being looked at to be included in IDE plugins and things like that, so you can?
I think that may be something that they're thinking about longer term, but it is not something that I've seen currently. They're mostly focusing on their SaaS, and then also being able to use these recipes inside of places like your Maven and Gradle builds. So you can say, these are the set of recipes that I always want to run as a CI check. And if they generate a diff, fail to build, or you know, at build time, just run the recipes anyway, so that they're always cleaned up the code, so that hopefully some maintainer will always be running those fixes in general, right? So you have a couple options there. And those are options that are available to you without a license for OpenRewrite and Modern. You can just install it in your build. So I don't think it's something they focused on in their IDE yet. I also think that JetBrains and Eclipse both have their own AST models, and so manipulating the ASTs in that way would require some level of interop between those two AST LSTs. So yeah. One of the things I often get to is what languages to support. It supports Java predominantly. They're working on Python currently. So they started with a Java AST, and they've added Python elements on top of the Java AST. So if you write a recipe for Java, it theoretically can also be applicable to Python in the right contexts. They also, so Java, Python, Groovy, Kotlin. They have other languages, XML, HCL. So you can, remember I was talking about fixing XML vulnerabilities. We finally have an XML parser that is format preserving. And then one of the languages they support is a language that is absolutely everywhere. Everybody relies upon it. Nobody wants to write it. Any guesses?
It's COBOL.
I heard it over here. COBOL, yes. So COBOL, they have COBOL support. COBOL is not open source. It's proprietary only, but they do have support for COBOL. Any other questions? Yes.
I saw you have, after a few years of doing this, you have a 40% commit rate. Why do you think, that's not higher, and how do you get people to commit
Yes.
to these goals?
So you'll notice this, yeah, so there's a lot. Good question. So So the question was why I've got a 40% merge rate on this here, right? But there's like 2.3% here, 7.6. What causes the impact on strength? Well, this one is a very simple security vulnerability. There's also a lot of them, but there's a lot of, as you'll find out, there's a lot of dead projects out there. A lot of projects that maintainers just, you know, that being said, I still get pings. I mean, these are all generated from my personal GitHub account. I still get GitHub notification pings that I'll see like, hey, this pull request emerged from pull request I generated in 2019. So it still happens. This one, 2.3%. JHipster is a code generator, and it was a code generator that was used to generate the like bootstrapped or basic Java project for a Spring project. The problem was that the JHipster code generator was generating code with security vulnerability in it. So there was actually like 15,000 plus instances of the same exact security vulnerability, same exact file appearing against 15,000 open source projects. You might ask me, why 2.3%? Well, a lot of those projects, when people generated them, they were like one-off. I'm trying this as part of a class and like that, and like I'm never touching it again, right? So they didn't really matter. But some portion of those projects were legitimate projects, so that's why we have such a low rate for that. This one GitHub did, and then these were just done in 2022, right? So 40% is actually pretty good. So we get about 40 to 25% ish, 20-25%. Most of it's not because the maintainers like raw go away. Most of it's because the project's just nobody's there. It's a lot of projects that are on open source that are just, as a really good indicator, right? This project is not maintained because the security pull request came in and nobody's looking at it. Yeah. Yes.
You've engaged with GitHub on some of these vulnerabilities and fixing them at mass. Do you know if they're working on any kind of continuous scanning to include like they do with the Pendabot for these sorts of vulnerabilities?
So they have CodeQL, right? So CodeQL is free for open source. It's something that you can actually, it used to be something that you'd have to add a GitHub action for. Now, if you go into your GitHub repository settings, there's a checkbox that you can just check to say, hey, I want to enable the default configuration for CodeQL. And now CodeQL will scan your repository and give you the alerts inside of the thing. The thing that bugs me about tools like CodeQL and things like that fall into this thing called SAS, static code analysis tooling. The problem with SAS tooling that I have struggled with for years is you spend all of this time tracking down the AST nodes that make this vulnerability up. You spend all this time, you get them in your memory, in your hands, and then you just let them go to report it to the maintainer to say, hey, you've got a vulnerability. Rearrange the AST nodes and fix the vulnerability. And that's the thing that I love about OpenRewrite is it finally gives us the ability to take these AST nodes that we have spent all this time with our SAS tooling detecting and actually rearrange them to fix the vulnerability and give the maintainer not just an alert, but here is the fix for this vulnerability that I've detected. Just merge it. That's really powerful. And that's something that no other SAS tool can do as far as I'm aware to this day.
How do you verify changes to make sure that you're not accidentally inserting vulnerabilities into open source projects as opposed to just fixing them?
Well, how do I verify to make sure that I'm not inserting security vulnerabilities into open source projects when I'm attempting to fix other ones? So one of the bits of suggestions is take your fix and vet it by another organization. I, for example, work with GitHub Security Lab, and I will say, here's a set of tests. Here's this test suite that I've run this thing against. Look through this test. Does this change seem reasonable, right? So getting a third party to say, you know, and GitHub also encourages us to because there have been other people that have followed up with this and tried to do this work, and they just generate code that will not compile. So following up on this work, Trellix is another security research organization. They were inspired by this work, and they went out and attempted to fix Tarslip, which is a security vulnerability involving Python. and the tar library was vulnerable to what basically zip slip, but tar files by default. And they generated 65,000 pull requests to fix that vulnerability across open source. Ended up setting a couple maintainers because they had some bugs in their code generation. All of that work actually finally got the Python core team to make a PEP to fix that vulnerability in the Python core library. So this work, making it that blatant that, hey, Python ecosystem library maintainers, you've got this problem everywhere, will finally get them to make a change to fix the vulnerability in their standard library. You know, it's sad that we have to play that game as security researchers, but it's effective at the end of the day. It has been effective, and hopefully that'll fix this for all time in the future moving forward. Yeah, that's a good question. Yes, I have 5 more minutes. Yes, go for it.
This is kind of a statement and a question.
Go for it.
I know we're in a security context here,
Yes.
but you know, it seems that these obviously would, these techniques would obviously help also with code quality.
Yes.
So, I mean, I get the same question all the time. Sonar finds all these things.
Yes.
It goes through all the effort of doing it.
Yes.
Can we automatically fix it? And I'm like,
Go talk to the
no.
Modern folks and go look at their recipes. Their predominant set of recipes. I saw their technology. So the question was, we have code quality problems, right? Like, this seems like it's not just security issues, it's also code quality problems. Modern and Open Rewrite was originally designed around the idea of code quality and fixing that problem and framework migrations. I saw it as a security researcher and said, that is perfect for fixing security vulnerabilities. That is not the predominant focus, unfortunately. I think it should be. I think it's a great market. But I am one of the primary people that's been writing and generating the security fixes to fix these vulnerabilities. But their predominant selling point is framework migrations, code quality improvements, getting your code consistent so that you've got a bunch of technical debt, right? Everybody's got technical debt. Let's go clean that up, fix it so you can deal with the things that your business needs, the security problems you're not dealing with. You know, has anybody ever done a framework migration? Like, you usually requires a senior engineer to come in and go through your entire code base for weeks sometimes to fix to get all things up, because they know where all the cobwebs are. If you could you could take that knowledge of this is what a framework migration is and code it in code and just get it deployed, it saves your organization so much time. Like, I've done framework migrations. I'm a software engineer turned security researcher. You know, I don't work for them. I'm not selling their product, but I see the value. So, yeah. And that, you also had a question, or that was it? Perfect. I have 2 more minutes. Any lingering questions? Yes.
For projects that haven't been maintained and you open up a pull request with a fix,
Yes.
does that make you the new maintainer?
No, no, because I don't have any permissions. They didn't give me any permissions. I can't merge a pull request, so no. I claim no ownership over the state of the world. I just try to. I've been analogized as the janitor of the open source. Like, I'm sweeping up all of the stuff that's just been left behind. So, and someone needs to do that, right? Like, these vulnerabilities are not new. These vulnerabilities are things that we have known about for years. There are blog posts about them. There are documentation on OWASP. I'm not doing, it's just that they're everywhere. They're just there because people don't fix them. So let's actually fix this stuff. Yeah.
I just want to say that I think one of the underrated parts of this is that even though like 60% of the HTTP downloads aren't merged,
Yes.
it's going to cause some SCA tools to fail code quality checks for new libraries. So even if it doesn't get merged, it's helping
Well, the thing is
at
that
least highlight.
yeah, so this, I mean, the 60% pull requests that are not merged, I don't think that anybody's taken that data and turned that into an alert that's like SNCC is flagging or something like that, hey, this project is not maintaining or merging this stuff.
It'll get pulled in as part of some of the tools.
Interesting.
Yeah.
I have, one of the things that I've discussed with the CVE board is, hey, CVE board, can we put a capper CVE on the end of a project version range that says, this version is no longer maintained and there's a vulnerability in it. And they're like, nah, that's like not necessarily, the end of a version range support is not necessarily itself a vulnerability. And I'm like, but it is if there's a vulnerability. Come talk to me about this afterwards. I'm out of time. I'll be around. I'll be carrying the duck around. I've got the hat on. Come chat with me. I'm here all day. And thank you all for having me. I really appreciate it.
Awesome. Great talk. Jonathan. Thank you so much. Good stuff.
Thank you. Thank you for having me.
Thank you for cleaning up the world.
Internet janitor right here.
All right, we got our next talk coming up in just 5 minutes.